Let us talk about the correlated subqueries. This is one of the more sophisticated and rather pretty ideas. And basic idea of correlated subquery is somewhat similar to having a loop. So notice that invoices has an alias invoice main. And in the subquery, we also have invoice main.vendor ID. So basically, this interprets this subquery average invoice total from invoices as invoice sub, where invoice sub vendor ID equals to invoice main vendor ID. This means for every vendor ID in invoice main, calculate an average invoice total from invoices. And this is what the subquery is for. All right, let's move to Studio and actually look at it. So I would like to understand this a little better. And invoice main vendor ID in the subquery is a variable which runs across all vendors' IDs in the invoices, in the inv main. And for every one of them, the average is computed across all invoices with the same vendor ID. So let us, instead of variable inv main.vendor ID, use a constant one. So just to understand this better, we select a constant vendor ID, 95. So this is the average. The first query results in one number, 28.5. And this is how it was computed, what it was computed from. So there is apparently 6 invoices with vendor ID 95, and their average is computed. Notice, of course, that some of the invoices are larger than the average. These 3 specifically are bigger than the average. Now let us look at the whole thing now, at the whole query now. So for every vendor ID in inv main, we computed our average. And now in the inv main, we're comparing invoice total to this computed average. So we are looking for all invoices which have the total bigger than the average total for this vendor ID. And hence, if we look at vendor ID 95, we see 3 rows of data retrieved, vendor ID, invoice number, invoice total. And the invoice totals are the ones that are bigger than the average, as we have seen in our previous discussion here. So these 3 are bigger than the average. All right, let's move on. Here is another query. It is also a correlated query because of identification here in where. So to understand it, not exists means that no rows are retrieved. The results are empty. There are no resulting rows from the subquery. What does the subquery do, literally? It selects everything from invoices, where invoice vendor ID is equal to vendor's vendor ID. So for every vendor ID in vendors, we look if there is data, any data, for the same vendor ID in invoices. That's the purpose of the subquery. And the big query retrieves the data from vendors where the results of the subquery does not exist. So where for this vendor ID, there are no invoices. And that gives the same results as a couple of queries we have seen earlier, one with join, another with a different subquery. All right, let's consider this query coded from the from clause. Here it is, the very same query. How can we possibly understand this? Okay, let's look at a subquery which gets a name top vendor, and actually the subquery itself is quite descriptive. We're selecting top 5 vendor ID for them, we're computing average total as average invoice. From invoices, we group by vendor ID. So we group by vendor ID, so averaging across all invoices with the same vendor ID, and then order by invoice, average invoice, descending. So the top 5 will be by average invoice. We're selecting the vendor IDs with the highest average invoice total. So the vendors who bill the highest on average. So that's the purpose of this subquery, and we can quickly highlight and execute as long as I don't include the parentheses in here. Here it is. So my average invoices are, so this is the average invoices and they are ordered decreasing. The biggest one first. Now, what do we do with this subquery? We use it as a temporary table. So we are doing a join of invoices with our custom created table, temporary table. Now it's worth noting that it's not saved anywhere and it exists only during the execution of this big query. Now, invoice, what are we selecting? Invoices vendor ID, max invoice date as latest invoice. So we are looking for latest invoice per vendor ID, and we know there is a group by here by vendor ID. So latest invoice, max invoice date, means latest invoice by vendor. But also we look at average invoice total. But we are not looking at all of them. We are doing a join with this select statement, which retrieves only 5 vendor IDs. So we're looking only for top vendors by average, and for them, we are computing the latest invoice. So in a result set, we will see 5 vendor IDs. We still recompute the average invoice total. We didn't copy it from here. We had to recompute it for every vendor. We're grouping by vendor anyway. And in this case, we order by latest, not by the biggest average invoice, but by latest. So we see that this data, average invoices, the values are the same, but the order is not the same. For example, the 4th is bigger than the 3rd in this table because we were ordering by latest invoice. So I think this is quite elegant. And a question you may think about by yourself, why did we have to compute the average again? Here is another example. Let's understand what's going on here. Select distinct vendor name and comma, select max invoice date from invoices where invoice vendor ID equals to vendor ID as latest invoice. So we can have a correlated subquery in the select clause, and just knowing that this is correlated, here is what we are correlating it on. So vendor ID from vendors, for every vendor ID in vendors, we need to find the maximum of a maximum invoice date. So the latest invoice date, and then order them descending. So the very latemost ones first. And we can do the same thing using join. Let's read this query. So we first join, then do a group by. So vendor name, max invoice date. So we are grouping by vendor name, and we're choosing maximum invoice date, the latest invoice. From vendors left join invoices. That means take everything from vendors and look for the matching data from invoices for example, to calculate this part. And we're identifying by vendor ID, invoices vendor ID. So the results are the same. And that is another example where you can replace the correlated subquery with the join. And whenever it's possible, it's probably a good idea to do that because joins generally work faster than subqueries. And sometimes it's very hard to do. If subqueries are sophisticated, if the statements you are working with are very sophisticated, it would be hard to replace subqueries with joins. And next, you will learn about complex subqueries and recursive subqueries.